Welcome to Elementary Algebra. The book is by Harold Jacobs. I'm your presenter, Molly Crocker. This material is copyrighted. Chapter 1, Lesson 5, Raising to a Power. Press pause, open a new browser window in YouTube, and search for Ma and Pa Kettle Math or Abbott and Costello Math. The videos that I'm suggesting show what can go wrong when place value is misunderstood. Let's do a little review. Write down some answers to these questions. What do we call the answer to a multiplication problem? If we add, the answer is called. When we divide, we have a. When subtracting, we are looking for a. In algebra, the parts that are added or subtracted. Let me read that again. In algebra, the parts that are added or subtracted are called. The parts that are multiplied together are called. Press pause and get all those answers down, and the next slide will reveal what I'm looking for. If you need to make flashcards for these, then press pause again and do so now. Review. Repeated addition can be restated as what? For instance, example, if I add 1, 2, 3, 4, 5, 6 x's together, then I can restate it as multiplication. We are condensing addition to multiplication. If repeated addition can be restated as multiplication, then is there something we can do for repeated multiplication? You should know this as an exponent. For example, if I multiply 4 times 4 times 4 times 4 times 4, that is written as 4 raised to the 5th power. 4 with an exponent of 5. The painting I'm hoping you can find shows a typical American child and several generations or ancestors for that child. You have 2 parents who contributed to your DNA, 4 grandparents, 8 great-grandparents, and 16 great-great-grandparents. That is what we call an exponential increase for each generation. We keep multiplying that number by the same base, 2 times 2 times 2. The painting that I'm hoping you can find implies that there could be a number of colorful characters and, well, interesting accidents in anyone's family tree. More on that in a genetics class, which thankfully I don't teach. This is an exponential expression. It has a base and it has an exponent. The word exponent and the word power are generally used interchangeably. However, typically we say it's an exponential expression. We don't typically say it's a power expression. It's just common usage to say it's an exponential expression. How should we read this expression when we say it out loud? We have 2 ways. The longer and more formal way is to say 2 raised to the 10th power. But as mathematicians, human beings that we are always looking for shortcuts, so we will often shorten this as 2 to the 10th. This is 4 raised to the second power and 4 raised to the third power. Or we could say 4 to the second and 4 to the third. We have a nickname for these two particular exponents. 4 with an exponent of 2 can be read as 4 squared, or the square of 4. 4 with an exponent of 3 can be read as 4 cubed, or the cube of 4. This is how we would say it if variables were involved. We could also say x raised to the second power and x raised to the third power. But this is x squared, or also the square of x. X cubed, or the cube of x. Where do these nicknames come from? Let's start with a length of 4 units. If you build a square with side length of 4 units, and it doesn't matter if the unit is inches or centimeters or something else, then the square has an area of 4 times 4, or 4 squared, which is 16 square units. 16 is the square of 4, or 4 squared is 16. A cube with all the edges the same length of 4 has a volume that we find by multiplying 4 by 4 by 4. And since it fills a cube, we can say 4 cubed. 4 times 4 times 4 is 64 cubic units. It could be a room 4 meters on a side holding air, or it could be a block of cement 4 inches on each side. The room would have a volume of 64 cubic meters of air. The cement block would have a volume of 64 cubic inches of cement. While I'm here, be careful how you refer to the exponent. Use 4 to the second, or 4 squared, or 4 raised to the second power, but never say 4-2. Your future math instructors will laugh at you and wonder who let you get away with that language. Besides, it's ambiguous. Do you remember what ambiguous means? Back to this idea of repeated multiplication. Since the order doesn't matter in multiplication, then it doesn't matter if we say 4 3s or 3 4s, or x 3s or 3 x's. Multiplication expands to addition, meaning when we spread multiplication out and show it as things added together, the expression is longer. Addition condenses to multiplication. If we change addition to multiplication, the expression is shorter. A similar thing happens with exponents and multiplication. Exponents spread out to multiplication. A condensed way of writing multiplication is to use an exponent. In the case of an exponent, we mean the base should be multiplied to itself, and the exponent tells us how many times. Check with a calculator. 3 raised to the fourth power is not the same as 4 raised to the third power. Here's an application of powers of 2 to computer memory. First, a little terminology. You've probably heard that computers only speak in zeros and ones. At the lowest level of machine language, that's true. So how are numbers represented in a computer? Here's a table of the numbers from 1 to 16 decimal, and how a computer, even one as simple as a calculator, uses them. How do we read binary? For instance, the number 8 in decimal would be read 1000 in binary. You might want to pause the video here and study this table and see if you can see the patterns. This seems unrelated, but hang in there with me. Here is a decimal number written in expanded notation. You can see the powers of 10, and the coefficients on those powers is easier to see in the second row. 30,000 is 3 times 10 to the fourth power. Binary works in a similar manner. Under the row with the powers of 2, I have written the decimal number equivalent to that power of 2. So you can see that 1011 in binary is 1 times 2 to the third plus 0 times 2 squared plus 1 times 2 to the first plus 1 times 2 to the 0th power. That adds up to 8 plus 0 plus 2 plus 1, which is 11 in decimal. In binary, remember bi in binary means 2. In binary, we call each digit a bit. One meaning of the word bit is a small piece. Another meaning is the past tense of the verb to byte. As the language around computing was developed, the software engineers latched onto that dual meaning and chose to change the spelling of a group of bits to eliminate confusion with the verb to byte. So, a binary number that is 8 bits long is called a byte, which is spelled with a Y. Then, to blend binary with metric, 2 to the 10th bytes is called a kilobyte. And you can see what happened in the table on your screen. 2 to the 10th isn't 1,000, it's 1,024. When computers first came into homes, their onboard memory, meaning the amount of memory they required to function, was no more than 64 kilobytes. Software that required more than that had to store intermediate pieces of data on a separate drive, usually a disk that could be inserted into a box with wires to the computer. The phone in your hand, as of this writing in 2024, can hold up to a terabyte of memory. It's a guess that the entire internet stores about 1.2 million terabytes of data as of this writing. That's still less than 1 terabyte per human on the planet. What would we do without exponents to say all this stuff? Here's a calculator trick for your homework. Turn your calculator on with the on button that's on the bottom left corner and press the Y equals button, which is, there's an arrow pointing to it on your calculator. You should be at this screen, and it may look a bit different than this calculator. This calculator is a little beat up, and there are some random lines around the edge of the screen. If you have anything in the Y list, then clear it by navigating to each line with the navigation pad arrows. Then press the clear button, which is just below the navigation pad. After it's all clear, navigate back to Y1. This is a screenshot of my TI-84 calculator emulator for a Mac computer. We are going to generate a list of powers of 3. In the Y1 row, type 3 raised to the x. You can see how it looks on the more modern TI-84s and how it looks on a TI-83. You can see the key presses that I used on the TI-84 at the bottom right. It's kind of in the middle there. You may have to do a little hunting to find all those buttons. The raised to button is an upside down V. That symbol is called a caret. It's not a vegetable. In the third row of buttons, you will find what we call the shortcut X button. And it's labeled X and T and theta and N. Depending on the mode you're in, and we'll talk about the mode button much later, this is what will appear when you press this button in the Y equals screen. Shortcut X. You want a quick X, press this button. What shows up for the TI-83 is on the overlapping screen, except for the colors and the strip across the top. Those two pieces will not be on your TI-83 screen. After you get an equation entered, go to the table by pressing the second and then the graph buttons. The second button is on the left-hand column. The graph button is highlighted in red in the top row. Don't press them both at the same time. You'll see a column that starts with 0 or 1 and a column that shows what you get when 3 is raised to that power. Let's talk about what's in these columns. 3 raised to the power of 0 is 1. More on that a little later. 3 raised to the power of 1 is 3. 3 raised to the second power is 9, or we could say 3 squared is 9. These should be familiar to you. Now, if you want a different base, then return to your y equals screen by pressing the y equals button and choose another base. X should be in the exponent position. To get back to your home screen, press second, then press the mode button, which gets you quit. Do you see the tiny word quit above the mode button? You get that when you've pressed the second button first. How's that for terminology? Calculator tricks like this will help you get your homework done faster, which both of us appreciate. Feel free to play with your calculator. If you get stuck somewhere and you don't know what it's doing, then show it to your instructor. That's all for now.